Do you remember when you're given a table how to find the inverse of a function? Okay. An inverse of a function is a reflection across the line y equals x. So, inverse is a reflection. Okay, since I can, I will. Across the line y equals x. In just plain old everyday, what do you have to do? You swap the x and y. Swap the x and y. Oops, I don't put that there because I'll have my elbow on it. So if I'm going to reflect a line across, reflect something across the line y equals x, when I swap the x and y coordinates, that takes care of it. So the inverse of this function then is just going to be 22, negative 6, 13, negative 3, 4, 0, and negative 5, 3. Do not change the signs. Do not change the signs of anything. Only swap them. So, right. So to help us with this next graph, we've been given 2 points that are definitely points on the graph. So what I want to do is I want to identify the coordinates. So this one is 0, negative 2. And this one is 3, negative 1. Right. Everybody agree? Those are the coordinates of those 2 points. So to get the inverse, we're going to swap those. So we want, for our inverse function, we're going to have negative 2, 0. So we go to negative 2, and we plot a point at 0, negative 2, 0. And then we want negative 1, 3. So we go to negative 1 and up to 1, 2, 3. And then let's see if I can draw a straight line. What is that? I think that means draw a straight line. Let's try. Oh, look at that. Except I can't get it in exactly the right spot. Oh well. No, I thought I had it. I'll just freehand it. So it isn't perfectly straight. But you will notice when we draw this line, if I draw a line that is, let's see if I can do that. If I draw a line that is the line y equals x, that one worked better. So this line is y equals x. You can see that the inverse is a reflection across that line. Sometimes we use this if you have a curve, you can create things like a vase or a butterfly or other things by reflecting across the line y equals x. Now, I will tell you this, and I will keep telling you this all year. I do SAT prep. Oh, and if you, no, you're 9th graders. If you're 10th grade, how many of you are 10th grade? If you are 10th grade or higher in today, this Saturday, not this Saturday, not the next Saturday. So 3 Saturdays from now, where this coming Saturday is 1, this Labor Day weekend, not the next Saturday, but the Saturday after that. I help with an SAT prep on Saturdays, and it's located at Duncanville, which is Dr. Smith's former school. That's where he was principal before he came here. So he has generously provided buses to take you there and bring you back. They usually provide you with water, maybe even snacks when you get here. There's a sign up on the Singley page, and you should have received, if you're 10th grade or higher, you should have received an email about it already. We need you to sign up as soon as possible if you want to do that. It's 4 Saturdays in a row. You don't have to go to every Saturday. I will give you extra credit for going because you will be doing math for about 4 hours. About 3 hours. You'll be doing math for about 3 hours. Practicing for the math SAT. Now, the idea for doing this in the fall is to get you in there before you take that PSAT. Now, for you, the PSAT, even if you do well on it this year, the PSAT won't count until you're a junior towards the scholarships. However, the more often you take these things and the more prep you do, the higher your scores. My daughter-in-law did, when she was in high school, I think she ended up taking the SAT 4 times or maybe 5, but she ended up with almost a full ride scholarship to Baylor. That's a lot of money. I mean, right now we're talking $40-something thousand a year times 4 years, because when you take it over and over, first of all, you get better at it because it's a test-taking skill. Secondly, because studying and prepping and retaking it, if you do, let's say you get really high on English one time, but not so well on math, then the next time really focus in on your math and do really well on the math. Even if your English score goes down, they'll still take the higher of the two. So when you take it multiple times, they're going to take your highest scores from each section when you redo that. So all of that to say, and I've been doing this SAT prep for, I think this is my 6th year coming up. On almost every practice test that the College Board releases, there is a question about inverses where the answer to the question is it's a reflection across the line y equals x. They really want you to know that. They really want you to get that concept in your head that when I take the inverse of the function, that I'm reflecting that function across this line y equals x. And graphically, visually, that is what the inverse is and what it's doing. So I'll keep repeating it until you're tired of hearing it probably, but I really want that to stick. That's at least one question you should always get right on an SAT test. All right, so any questions about this one? Okay. All right, so anybody not have this copied with all I was talking? All right, so now I need to move it up. All right, so okay, we're going to do these bottom two ways, because one of the things I don't know if you're going to remember it from Algebra 1. So the first thing we're going to do with the one on the left is we're just going to find the inverse and see if we get the other equation. Right? So to find the inverse, it's just like what we did with the table and with the graph. We trade places with the x and the y. So you know that f of x just means y, right? So we have 7/2 minus 3. Oops, I left off the x. So the first thing we do is we swap the x and the y. Only the variables, not any of the numbers that go with them, not the signs that go with them, just the variables themselves. So now we have x is equal to 7/2 y minus 3. And now we solve for y, just like you did in problems 3 and 4 at the top of the homework page. So the first thing we have to do is add the 3. So now I have x plus 3 is equal to 7/2 y. They don't like for us to teach you tricks, but let me just ask you, do you know PEMDAS? Yeah. When you're doing this to solve for y, it's PEMDAS backwards. Add and subtract first, then multiply, divide, then your exponents, then your parentheses. So PEMDAS backwards when you're solving these, if that helps you. The other thing, there are a lot of tricks that people teach you for how to divide by a fraction. Because this 7/2 is multiplying by the y, so this is multiply right here, right? That's a multiply dot. Because it's multiplying, I have to divide by 7/2. Do you remember when you're dividing by a fraction what you're supposed to do? Multiply by the reciprocal. So I'm going to write it this way because I think it will help you remember. If I multiply this by the reciprocal, which is 2/7, remember everything I do on one side, I have to do on the other side. If I multiply this by 2/7, then what's going to happen is my 2's cancel and my 7's cancel. And that's what I want, because I want it to equal a 1. So if you've learned it a way that works for you, use that. If this helps you remember what you have to do when you're solving these and there's a fraction in front of it, then do that. So then my final answer for the inverse is y equals. Now, they're writing it in slope-intercept form. If we write it in slope-intercept form, then we have to distribute the 2/7. So then this is 2/7 x plus 6/7, right? Because 2/7 times 3/1, you multiply across. So to get 6/7, I have 2/7 times 3/1, right? So we multiply across to get 6/7, right? Just an aside. Is this what they gave us? Is this function here the same as this? No. So these are not inverses. No. Okay, do you remember composition of functions from Algebra 1? Anybody? No? Yes, maybe? I have a picture I want to show you. So what we're going to do now is we're going to take, resume. Oh, nope, that's not what I wanted to do. Okay. Go back to this one. Okay. So I have f compose g of x, and I have g compose f of x. Right? So we're going to take the function g, and we're going to stick it into f. Right? So f of x, so f compose g, we'll do that one first, means I take f, which is 2, and where the x goes, so I'm going to take this whole function and I'm going to stuff it in there where the x goes. So then I write 1/2 x plus 7. And then the rest of this function is still there, so I still have my minus 14. So in place of the x, I replaced the x with all of g. I put g into f. Now I have to do the math. So I distribute this 2, right? So to distribute the 2, 2 times 1/2 is 1, so that leaves me with x. 2 times 7 is 14. The minus 14 is on the outside. Plus 14 minus 14, this is 0. So this is equal to x. So I put g inside of f. Now, I'm writing very large so that you can read it, so I'm going to use the other side of the paper over here to do the rest of this. Now I need to do g compose f. So I'm going to take the function f, and this time, I'm going to stick the function f inside the function g. So I start out with my g, which is 1/2, and then where that x is, I put all of function f, which is 2x minus 14. And then the rest of g is plus 7. Now, right now, I need to know that you understood what I just did. Okay, that's what I thought. If I write, let me write it out, 1/2 x plus 7. You understand this is g of x, correct? Yeah. Anybody not understand that that is g of x? I just copied it. What I have to do is I have to take this x right here, and I'm going to replace it with all of f. Did you follow that? Yeah. So I'm going to pretend there's parentheses around this x right here, and I'm going to take f, which is 2x minus 14, and I'm going to stick it inside those parentheses instead of that x. I'm going to replace it. So that's where my 1/2, my parentheses, all of f, which is 2x minus 14, is now right here where that x used to be, and then that plus 7 is still there. Now, did that help? Is it at least a little bit more clear? Those of you who were lost, did you follow that part? So now we distribute the 1/2. So 1/2 times 2 is 1, so I have x. 1/2 times negative 14 is negative 7, and the plus 7 is still there. This is equal to 0, so now this is equal to x. That is the test to determine if two functions are inverses of each other. So I'm going to write out the test. The rule says if f of g of x equals x, and you have to test it both ways, g of f of x equals x, then f of x and g of x are inverses. Now, if you got this, you know how to do this, you can do this composition already. While I'm still working with a couple others, what I want you to do is I want you to see if you can come up with two functions where f of g of x is equal to x, but g of f of x isn't equal to x. So if you understand this, you got this, you have no questions, you don't need any help on it, then I want you to just take your pencil and take a few minutes and see if you can come up with a question where it works one way but not the other, because it has to work both ways to be inverses, right? That means you. Yeah. Do you have your pass for your 3 times on it? And your syllabus? Oh, it's probably still easier to get to that second room. These arrows are going forever, so that's going to go forever, not just to negative. Oh, okay. It's going to start at -4 and then go, so start at -4 on this side and go to infinity on that side. And then this one is from -infinity up to, this is less than or equal to because the dot is closed.
Oh, yeah, that's what that is. I thought, well, all of the dots were closed. So
yeah, but that's the one at the end.
Yeah,
so
okay.
This was just letting you know what some of the values of the points were, I think.
Okay.
And then it's going up to 1, but it isn't stop. I mean, there's a dot there, but it isn't stopping. So this is going to be -infinity. Yes. Okay, over here. Did it make more sense when I went through it the last time, or is it still confusing? Okay. Did you understand my pizza illustration? That one of them I had a pizza and I took the pineapple and put it on the pizza. The other one I had pineapple and I put the pizza on top of the pineapple. Right? That's the difference between what we're doing. One of these we're taking the function f and we're taking g and we're stuffing it in there. So it's like putting the pineapple on the pizza. We're taking where the x is currently and replacing that x with all of the other function. And then we just do algebra after that to see if we end up with an x. Okay? The reverse of that is when we take the other function like g, and wherever the x is, I'm taking the f function and I'm going to stuff that in there where the x was, and then I'm going to do algebra and see if that's equal to x. Okay? Working with it should help, but I want to make sure you at least understand what you need to do. Right? Okay? Because that's this inverse stuff is all about, and this composition of functions, which means putting one function inside another function, we're going to keep using that throughout the year, but it's critical right now for some stuff that we're about to do. Okay? All right. Over here, anybody questions? On the switching the x and the y and solving? Okay, for that one, you know how I told you to solve for y on the homework 1, and we looked at that? So what you're going to do is you're going to take the x and the y and trade places with them. And then you solve it for y like we did on that first problem in the homework. So you do the reverse PEMDAS steps until you get y equals. When you've done that, that is your inverse. Yes.
So these are two completely different methods?
Two completely different methods. One was just finding the inverse algebraically. The other one is a test to see if they are inverses.
Okay, so like if we did this method for this equation and it matched up to this with it,
That would be inverses. Yes.
because that's what I had done at first.
Yes, yes, that is one method. But you also need to know the composition method. Which, yes. So now on the back it says you try it. So you try it.
Post link.
You know what?
What day is it?